All right, welcome. This video, we're going to talk through some of these density and measurement practice problems. So these first couple of problems have to do with density, and this one we're trying to identify an unknown piece of metal. So you find a mysterious ring, you want to figure out what type of metal it is. You find that its mass is 43.68 grams, and then we measure the volume using water displacement. So we put 4 mils of water in a graduated cylinder. After you add the ring, the volume is now 6.26 milliliters. So we want to identify the metal by using density, and then density is the mass over the volume. And the mass we measure directly, it's 43.68. The volume, we have to figure out by doing this subtraction, right? We are using water displacement to figure out the volume of our metal. So my mass was in grams, and to find the volume of metal, I subtract the total volume from the volume of just the water. So our mass is 43.68 grams, and if we subtract these two numbers, it looks like the volume of our ring was 2.26 milliliters. Noticing how I'm labeling each of my numbers with units, that's something you want to do. And then when I divide this, I end up with a density of 19.3 grams per milliliter. So I can go back and look at my table of given values, and it looks like my ring is gold. Hooray. So I've identified the metal based on its density. This next one, it's a variation. Rather than calculating density, we're asked to find how much space something will take up. So how much space would be its volume? So I can rearrange my equation. So density is mass over volume, and I can rearrange it. I'm going to multiply both sides by volume. Let's walk through the algebra here real quick. So that's volume times density equals mass, but I want to solve for volume. Sorry. So I'm going to divide both sides by density. Boom. And it ends up like this. So volume is the mass over the density. And another way you can think of this, you see this triangle, this density triangle. We put it in one of our notes here. Density is mass over volume. So basically, and there's little dividing signs here and multiplying signs here. So the idea is, like, let's say you want to find volume, you take mass divided by density. Or if you want to find mass, you take density times volume. So volume is mass over density. Okay, so my mass is 100 grams. My density of iron is 7.85 grams per milliliters. So it's 100 divided by 7.85, and then my answer is going to be 12.7, and that's my volume is in milliliters. That's my units we're using there. So that is how much space my iron will take up. And then let's look at this last density problem here. You have 100 grams of silver, 100 grams of aluminum. Which one would take up more space and why? So we could do this mathematically, or we could just do it theoretically. Let's talk about it in, theoretically first. So silver has a density of 10.5 grams per milliliter. And then aluminum has a density of 2.7 grams per milliliter. So aluminum is less dense. So you want to think about what that means. So that means there is less mass per volume. So if you want to get 100 grams of aluminum, you're going to need a larger volume of aluminum than you would silver, because silver is, more dense. So that means it's, more mass per volume. So to get 100 grams of silver, you need a smaller sample size than you would aluminum. So I need more aluminum. So my aluminum would take up more space. Okay, if you want a mathematical reasoning, we're trying to compare the volume. So the volume is the mass over the density. So the volume of aluminum would be the mass of aluminum, 100 grams, divided by the density of aluminum. Whereas and if you plug that in, 100 divided by 2.7, that would take up 37 milliliters. And then if you want to calculate the volume of silver, the symbol for silver is Ag. We'll talk about that more later. The mass is 100 grams. The density is 10.5. So we can see we're dividing the same mass by a bigger number. So 100 divided by 10.5 is going to give me only 9.5 milliliters. So notice how my silver had a smaller volume. So that's more evidence that my aluminum is taking up more space. So that's an application of just thinking about the concept of what is density. Okay, now let's look at measurements. The idea behind measurements, you want to record a measurement accurately with the correct number of digits. And the rule is you guess one beyond what you see. Whoops, beyond what you see. Another way to think of it is the last digit that you write in the measurement is the thing that you are guessing. So the last digit written is the guess. Okay, so if we look over here, let's zoom in on this. We've got this ruler here. It looks like each of these lines represents 0.1 centimeters, okay? And it looks like our box is somewhere between 1.2 and 1.3. So I know for sure it's a little bit more than 1.2 centimeters. And this last digit I have to guess. Where in between? I'm going to say 1.25. You also could say, 1.24 or 1.26 or anything in between that range there. So this last digit that we write, that's the one we're guessing. We're not exactly sure about that one, but we know for sure it's 1.2 something. All right, the yellow rectangle. Oh, it's not yellow in this picture, but pretend this is yellow. Okay, so your rectangle, I know it's somewhere between 4 and 5. And I have to guess where exactly though. So I'm going to write 4.7. Or maybe you wrote 4.8, or maybe you wrote, 4.6. But the idea is we're guessing on this last digit. We don't know about the 7, it's a guess. Okay, here's a rectangle. It's actually the same size, but with a more precise ruler here. So now we can zoom in and see, okay, now each of these lines represents 0.1. So this is like 4.5, 4.6, 4.7, 4.8, and we can see it's actually somewhere between 4.8 and 4.9. So I'm going to say that my answer is maybe 4.83. Or again, you could our last digit could vary. So maybe you wrote 4.82 or you wrote 4.85. That's all fine. The key thing we're looking for is realizing which digit we're guessing on. One more here with the temperature. So here the temperature goes up by 1 degree each time. So it looks like our thermometer reading is right now at 21, 22. It's somewhere between the 23 and the 24. So I'm going to guess that it's 23.2 because it looks closer to me to the 23. Our last number may vary. So maybe you wrote 23.1. Maybe you wrote 23.3. Maybe you're at 23.0, that's fine too, but we should be recording to the tenths place. This last one's a little bit trickier because in this one, the markings are every 0.2. So this is like 3.2, 3.4, 3.6, 3.8. And I would still argue on this one, we're still unsure about the tenths place. So I would record it as it's somewhere between 3.4 and 3.6. We're not exactly sure where. So I'm going to say 3.5 milliliters, but I'll try and avoid a scenario like this on the test because this one's a little trickier to decide how to handle this one. All right, let me know if you have any questions.